Hi, Eric Archer here from Texas Instruments, and today's Smart Space video lesson features the Hip Hop M.D. And the Hip Hop M.D. is going to take us through the power of Earth. And I think Hip Hop M.D., are you going to talk to us about energy and some Newton's laws and stuff like that?
Oh, absolutely. There's so much to get to on energy. So I'm super excited to talk to you guys about this topic. It's going to be very interesting and very engaging. So hope we learned something today.
Yeah, I think we will. I'm excited.
Yes, definitely. Awesome. So I will take it away. So yes, we are today talking about the power of Earth. We've been talking about all sorts of dynamics of Earth. We went through space exploration and what the Earth is made of. But now we're going to go inside the inner workings of the planet Earth. And we're talking about energy. But what is energy, right? I know we're all familiar with energy drinks, right? Red Bull gives us wings, right? I got a protein shake that I'm drinking here today because this is actually great for my workout. I just had a little workout this morning, so I was exerting energy. That's sweating, right? Sweating is a form of exerting energy. So there's so many different things about energy that exist all around us. We have cords like this, power chargers that we now connect to our phones, that gives our phones batteries life. That's a form of energy. Energy is all these different things around us that power things. And so today we're going to dive into a little bit more and understand exactly how these forms of energy works. What is it about Red Bull that actually gives us wings? What is it about our chargers that enables our phone batteries to get life? And even protein shakes and workouts, how do all those different elements affect us? So we're going to dive into here, and I'm going to share a quick little PowerPoint presentation, and then I'm going to kind of show you guys some examples. So I'm going to pull up my screen here, and we're going to take a look at this slide. Hopefully you guys can see this right now. Boom. So the power of Earth. So we're talking about energy. And in the simplest terms, energy is the ability to do work. Everything in our universe has energy. We explored all these different elements of space and all these different planets and what made up these planets and how the moon and all these different things were formed. Those were all formed by energy, everything down to the atoms and nuclei. And we use energy in our day-to-day activities while we're eating, consuming food. There's a reason we eat food, because when we eat food and our body processes it, that's a form of chemical energy. We have the different endorphins, the different chemicals that are releasing, proteins, carbohydrates within our body. All those are forms of energy. So even internally, we use energy. When we're running and walking, your body is sweating. You're releasing sweat because your body is exerting energy. It's forms of chemical energy. And in technology that we talked about with our phones, different things that we use to power things around us, the lights that are in our homes, all these different things use energy. Even visible light, the light that we get from the sun is a form of energy, because plants use something that's called photosynthesis, which we'll dive into as well in a little bit. So in order to really understand the fundamentals of energy, there are three different things that I want to showcase to you guys. And I'm going to kind of showcase some different examples. Everybody's heard of Newton's laws, right? And sometimes it sounds complex, but we're going to make them really, really simple today. We have the law of inertia, which says any object will be made at rest or moving in a straight line unless acted on by an opposing force, okay? And we're going to dive into a little bit of that in an example. We have the second law, which says the momentum of a body is equal to the product of its mass and its velocity. Force equals mass times acceleration. We're going to remember that. Now we have the third law, which is law of action and reaction. When two bodies interact, they apply forces in equal magnitude and opposite directions. So how do we really now take those forces in and really apply them to different things that we do in life? So we're going to do some little, talk about some examples, right? So unfortunately, I don't have a football with me, but if I did, some of you guys are sports enthusiasts and you're playing football or basketball, I do have my can of soda in here. So we're going to think of this as a football, right? So I'm Tom Brady. I'm one of the best football players in the world, throwing a football. So we talk about the first law: an object will remain at rest or continue moving unless acted on by an opposing force. If I throw this football, eventually this football is going to either get in the hands of a receiver or eventually just going to slowly fall back down to earth. Now we know why it falls back down to earth, right? That's because of gravity. But there are other reasons why this actually doesn't remain moving. If there were no other forces, if we didn't have wind force, right? Because obviously you throw this and sometimes you're in a windy environment. So you throw this football and it's flying through the air. You have wind which is resistant forces now, which are pushing against this. There's turbulence, all these different forces they're acting on there. Sometimes you have friction forces, right? If this football was, let's say this was actually like a bowling ball and it's rolling along the floor, you have friction forces, which are the frictional forces on the floor, which are now pushing against this as this is rolling. So eventually this isn't going to roll forever. It's going to stop because of those friction forces. But if we didn't have these opposing forces, this football or this baseball, or let's say I was throwing this Red Bull can across the room, will continue moving all time, forever and ever, until another opposing force was acting upon it. So the only reason this actually falls is not because of gravity, it's because of all these opposing forces. And that really is defined by Newton's first law, that will continue moving until acted on by another force. And then we have what we talked about with the conservation of energy, right? So the one thing to remember is energy can never be destroyed or created. Everything has forms of energy. So let's say we had a space shuttle that's taking off. We recently had a rover that just went to Mars. And so we had a space shuttle with all this thrust force that was going upward, okay? These forces now are applied in order to be able to shift this out. And we talked about gravity being a weak force. So if we have all these different explosives that are taking this shuttle into orbit, right? Those forces now from the space shuttle, because it has a mass that weighs something, just like we weigh something. If I was standing up here and I jumped into the air, I have a mass and I exert a certain amount of acceleration into the air. That now creates an upward force. And so that's what we talk about when we talk about conservation of momentum, force, and something that has mass. If we make some movement, that mass is always moving. So force equals mass times acceleration. And then we talk about things that have opposing reactions. So I'm obviously sitting down in my chair. If you have my can of Red Bull, or if you have a charger that's sitting on a desk, there's always multiple forces. So this charger is sitting on my hand. Gravity exerts a force downward. But there's also a force that keeps this right here, and that's this normal force. We already call it normal because it's a force that's always there. My hand provides a normal force. So I have a force that's equal to the force of gravity, which is going downward, which enables this to stay right here. Just like I'm sitting down in my chair, the normal force in my chair moving upward, and gravity keeping me downward. So those are different forces and how we explain Newton's 3 laws right there, which is very, very, very simple. So I'm going to go back to my slide here real quick because we have another element which I think is very, very, very important for everybody to know. So I'll pull this back up here to my PowerPoint. Boom. And we are going to talk about forms of energy. So mechanical energy, the energy possessed by an object due to its motion or position. And this is summed up into 2 forms of energy. We have kinetic energy, which is the energy of an object by its motion. And we have potential energy, which is the latent energy of an object at rest. So kinetic energy and potential energy. These are very, very, very important things to know. So it's going to be a little difficult here because I don't really have a full view to be able to kind of showcase, but we got this tray, right? This represents a ramp. Some of us have been out biking or roaming through doing bikes. I used to do bike jumps and stuff with my off-road bike, and to be able to take leaps, right? So you have ramps that will take you into the air. So we're gonna use this as a ramp, okay? And we're gonna have an object. Just because I'm a scientist, I got test tubes laying around. So we have a ramp here, okay? And obviously we've all maybe rolled down a hill or gone down a hill in our car. If I let this go, obviously we know what this is gonna do. This is gonna roll downward. But we talk about mechanical energy being broken into 2 different elements. We have kinetic energy and we have potential energy. When this test tube is sitting at the top of this ramp right here, this has what we call potential energy because it's at rest. It's not moving yet, but it has the potential to move, right? Obviously, it's being held down by my finger, and so it's kept in its position, but it has the potential to move, which is why we call it potential energy. So it has a amount of potential energy in here. Once this now starts rolling, once I release it and it rolls downwards into my hands, it now has what we call kinetic energy because now it is moving. So this obviously has a mass, it weighs something, doesn't weigh a lot, but it does weigh something. And as it moves down, we have gravity forces, which are bringing it down. And that's what we call the acceleration. And then it has this mass. So we talked about force equals mass times acceleration, which is also Newton's law. So all these are all tied together. The fact that we have kinetic energy, the fact that we have potential energy at the top and then moving into kinetic energy as it moves downwards, these are how now all these are summed together in order to make up the whole field of mechanical energy, which is very, very important to know. So those are simple examples that you can all see and try at home. So if we go
Hey, Hip Hop M.D.
Yes.
Hey, sorry to interrupt you. That was a cool demo. I appreciate that, and trying to understand. So potential energy and kinetic energy. So potential energy is sort of energy at rest. In this case, you had a test tube on a ramp.
Yep.
So up here, and then it has high potential energy.
Yep.
And as you let it go, its amount of potential energy started to decrease, and its amount of kinetic energy started to increase. And they did that sort of at equal but opposite rates. Is that how that works?
That is exactly how that works, right? So we talked about energy can never be created or destroyed. So the energy always remains the same within this body, within this system that we have with this ramp and this object. So it has potential energy right here at the top. And as it rolls down, it gains kinetic energy. And that kinetic energy now becomes more than the potential energy, right? So as it's moving, that kinetic energy is greater. And then eventually it stops again. And then now that's now reverted back into potential energy. Because within this, we have all sorts of different forces. As it's going downwards right here, we have frictional forces that are going opposite of it, right? Because there's friction here. This is a rough surface.
Oh,
so
right.
it has to move down smoothly. So those forces now act opposite of it. But all those forces all remain the same sum. So we talk about the sum of these forces. All of them all equal the total magnitude of all these forces. They just change as this now rolls down this system. So that
makes sense. Awesome. Thank you.
Conservation of energy. So we always mean that energy can never be destroyed or created. It always remains the same. So if we go back into my slide here, I'm going to pull up my screen really quick because this is so cool. We're talking about what powers Earth and how Earth is made. So we're going to go into this energy back in here. And so we talked about different types of forms of energy, right? My Red Bull gave me wings. It's a form of kinetic energy and chemical energy within our bodies. But we have also other forms of energy, right? We have elastic energy. We've all seen springs that we use. We have springs, maybe as shock absorbers in our car. Maybe if you have a pair of new Nikes, new Jordans, you have a little air bubble, which kind of acts as kind of a shock absorber, right? That kind of translates different forms of energy. Yeah, and chemical energy that we talked about from the food that we eat, carbohydrates, fats, even water is a form of energy because we need water in order to survive. Plants use what we call photosynthesis, which is now converting the sunlight into energy. So you have water, and you have the soil, which it needs for most plants, and then the sunlight. And then now that converts into an equation which actually releases oxygen into the air. And so we talk about that conservation of energy. All that energy still remains the same, but we now as humans use that oxygen that was created in order for us to be able to have life, which is very, very important to know. And if you really want to kind of talk about simple examples, we have a rubber band. We talk about elastic energy. It's the same thing like we had when we have the test tube rolling down the ramp, right? Conservation of energy. So in here, what we call this has elastic potential energy because now as this rubber band is laying loose right here, it has the potential now to exert a force. So that has what we call stored potential energy because all of that energy is stored inside the spring. And so this has something we call the spring constant. So as now you stretch this out, now that stored potential energy becomes greater. Now this now has the ability to exert a force. And now this has the potential energy. And if we had maybe like a bow and arrow, or we just wanted to launch this into the air, now this having a mass and now an acceleration because of that stored potential energy, now this has the ability to do work and now be able to translate into the air or be able to shoot something out of it. So simple things like a spring, simple things like shock absorbers in your car, simple things like air bubbles in your shoes, all these different things store energy and translate energy into other forces. So that's very, very, very cool to know. Next time you're playing with a rubber band, you know this has stored potential energy inside of it, which is awesome. So, but how do all these different forms of energy now translate into things that we use? So this is kind of the last kind of topic that I'll dive into a little bit here, because we use all these different forms of energy to actually help us live and help us survive. So we have the way that we convert energy into power. So over here, we have a picture of a hydroelectric plant or a dam, right? We've seen dams and rivers and lakes, and there's a reason why a dam is created. The water, the movement of water from rivers and lakes now that's going through this narrow passage. Now we take that movement of water and it's able to move what we call turbines, which now spin, right? And now that spinning of that turbine now translates into a form of power, which gives us electricity. We have windmills. If you've seen windmills, if you're out in middle America, and sometimes if you're out in desert areas, which are very, very windy, we have the ability to be able to convert that wind power into energy. And that's a form of kinetic energy, because as the wind now blows those, that blows the turbines and blows those ends of the windmill, now that starts to spin. And just like we had with our rubber band where we stretch it out, right? All that now has potential energy, which now gets stored into these turbines and into these vessels that will now be able to create energy. And then even inside our cars, in order for our cars to be able to drive and move, we have internal combustion. We now ignite that engine when we turn on our car, and that sparks now. And then now that creates a form of chemical energy, and we start to burn fuel. And that burning of gas and fuel now moves the engine parts, right? And now that's able to translate into the axle that now moves our wheels. And now our wheels able to roll, which gives our cars energy and gives our cars the ability to move. So I think it's really, really important to really understand exactly how those forms of energy work. We talk about mechanical energy, kinetic, potential energy. All those things are stored into one mass. And if you have a mass, you have acceleration, which gives you forces. And that's how we're able to do things like power these lights that are on here. When we have the chemical energy and we drink this, all that now, the energy from here goes into our body, and we convert that now, and that exerts all these different elements. So none of this energy is ever destroyed or created. It's either released or it's converted into another form of energy, but we use it as humans. Animals use it to survive. Plants use it to be able to survive, and the earth uses it to be able to maneuver and do everything that we do here on earth as it orbits around the sun. All these different things take energy. So I hope that gives you guys a little insight about energy and how that translates into the environment and the work we do. Isn't that pretty cool, Eric?
That's really cool. I'm excited. This was a great video, just because you took the concept of energy, which is a really big idea, and you kind of gave us a bunch of different examples of how it works. So, another example might be when, you're working out, like you said, you did a workout a little bit before, and your muscles are warming up, and so you're losing energy because of heat.
Yep.
So your body gets really warm, but that energy doesn't disappear or get destroyed. It just gets converted to what you were saying, and then it turns into heat. Is that right? Am I thinking about that right?
Yes, that's exactly right. That's exactly right. That energy never goes anywhere, right? When we work out, now we sweat, and our body is now releasing those energy, right? So it's a waste product of us using that energy. So us sweating and the heat coming off our body. Sometimes if you're working out in the cold, you see the heat, you see the vapor now rising from your head. All those different things are forms of converting energy. That vapor is from the sweat in your body now as you've been exerting work, right? Because we call energy the ability to do work. As you've been doing that work now, that now translates into different byproducts and different waste products. And so that energy is never lost, it's never created, it just translated into different forms around us.
Very cool. Great job, Hip Hop MD. Thank you for this video. I think this was great.
Yes, absolutely, absolutely. So next time you're powering your cell phone or drinking your Red Bull, you'll know exactly what's happening.